Okay, so first of all, my name is Milan. I work with Equifax, and we are also heavily hiring and at many different levels, all together from senior architect to architect. And primarily, we do mainly on the data. So any kind of big data experience, and especially on the cloud, you have a kind of a big vision to go to the cloud by 2020, and the entire Equifax want to go to the clouds. So we are heavily looking for many people in the clouds, and especially on the Google Cloud. So being said that so today I'm going to talk about Kubernetes RBAC. So how did it got started? So anything in Equifax and whatever be the technology, if it's extremely cool, uh, it's great. It's good for playing, but it's not going to be. We're not going to put it if it doesn't have a rock solid security in it, and especially after a hard learning after that went bad in a couple of years back when the data breaches happened. So anything, we don't even trust each other when it comes to system security comes to the picture, and everything kind of in our security teams have always a suspected eye on each and everything. We have many different networking agents, and all the images and everything gets scanned, and especially if you are using the Docker, that is more suspected now. So we kind of use the Docker. We download the Docker code. We change the image of that. Basically, we kind of harden those base image. If you're like something like Python 277 or Alpine, we don't use that. We change the root password for that and everything, and then we create our own images to build it. And when we build it, we don't go to the internet. We do it internally with our kind of a repository. So that's how it is. It's very difficult to build a Docker image, but we do it in a hard way. But we want to make sure that's absolutely rock solid security. So being said that, role-based access control, we had many different things. We have a multi-cloud platform. We are on the AWS, we are on the Google, we have an on-prem. So it's in a many different places. And what we are really struggling right now on the having a kind of unified access control all over in the multiple cloud. And we are not yet there, but we are doing it in many different ways now. It's kind of giving us something, but eventually the end goal is to go there. So that's how the research is going on many different technologies. So I'll talk about a little bit on each and everything today. And at the end of this thing, as I'm the only speaker, so I'll have some time. I possibly will go through a demo and how, and especially the demoing on the Google, how we can, and Google is actually a master in the Google Kubernetes engine. I have worked with AKS and everything, OpenShift, even if the Google is possibly the best one. Okay. A little bit about me. So first two lines I already explained. I work with Equifax, and that's not a lot interesting. But when I get time, I am a photographer, and I really enjoy that. And maybe some days I'll start as a kind of that will kind of come on the top, and first one will go down in the second space. So my main role, eventually I want to be a photographer at some day. So that's how this is quite a bit about my journey in the last 15 years. I started during my college days. I used to be a programmer. I started as a Java programmer, and then eventually Java in the Python, Scala, and Spark. And right now I am kind of started doing some Go programming, and that's because of the Kubernetes. A lot of cool knowledge is there, so that's not yet there. So I did many different things. I worked on many years with the IBM technologies and the MQ. Sad to see they are dead, and especially the ESB is dead. But it's kind of it had some vision, and it's doing many good things for many different companies. And BPM is still there, and then big data. So now we know that big data is also kind of taking a kind of a toll because of the Kubernetes. And all these technologies, if you see here, whatever I have listed, it's actually the reason they are struggling because of the Kubernetes and the clouds. Everything from the ETL, ESP, BPM. BPM is still there because that's not I don't say that's a technology, that's a concept. Okay. And so for Equifax, we have, what do we sell? We sell data. Actually, you have nothing else to sell. We don't have retail company that we don't sell products. We actually sell only data to many different banks, financial institutions. You take a home or go to buy a kind of a home. They do the checking. So everything is there on the Equifax. Is all depends on the data. So the data security is the most important piece of it. So people who have some background, this slide is more about kind of who are doesn't know about the authentication and the authorization process. So any system we would like to develop, the first thing is authentication. So authentication and then the authorization. So I'll spend a minute here to talk about what is authentication and authorization. So the analogy I can give you, like if you are trying to kind of rent a car and you put on your driving license, and that tells you who you are. That tells you, yes, you are the person A, you're John, and yes, and are you is your license valid? Yes, your license is valid. So that's called an authentication. So you have the right passwords to get into the system. But that doesn't tell you that what can you do. Can you drive a CDL? Can you drive a luxury car? Or can you drive something like a Porsche? Maybe no. And that depends on your kind of how much insurance do you have. Do you have any restrictions on that? That space I kind of call it as an authorizations. So authorization is after the authentication, next step is authorization, where you are identified that what you are capable of doing and how long you'll be able to do that. So authorization sometimes kind of it's not about that you will be. It's always typically the authorizations comes with an expiry. So now what can you do and how long you can do. So that is authorization. And then based on that, after your successful authentication and you're authorized, you will be assigned a kind of in a car based on your driving license. It could be assigned a CDL, it could be assigned a normal car, or depending on that. So this is kind of real world analogy for authentication and authorizations. Quickly, I'll jump back to RBAC. This is and it's a so big concept, and I typically kind of try to cover it in. If somebody asks me to kind of explain me what is the RBAC, so our RBAC full form is role-based access control. So it's typically it has three things. And one is the subject, and now subject is that who you are. Are you are you a developer? Which group you are? Are you administrator? Are you a system user? So as a person, you have to identify that who you are. It's not your name. Basically, this is after the name. As I said, that what can you do? So basically, which group you belong to. And it could be, so as I said, that it has two things. You can be a subject, like a group, or it could be an individual, who you are. So subject. Second thing, resources. What are the things that you can do? So yes, I can do resources. So these are the Kubernetes resources. I can do pod. I can do config maps. I can do services. I can do autoscaler. I can do deployments, node increments, and many different things. Sorry about that. And third thing, on which resources, what can you do? Okay. So if you look at this, I'm saying that the following resources: services, endpoints, and pods. You can do list, get, create, watch, delete, and patch. So these are called verbs. So this is the kind of backbone of a Kubernetes or RBAC, and I think it's kind of true for every kind of a system is that, but this is Kubernetes is very much highlighted because Kubernetes is very much work on the resources perspective. Not all system does it like that way, but Kubernetes purely on the resources and the operations. Right. So operations are kind of very much kind of you can do it at any level. You can do it at star. You can do it at the fine grain, like only get, only list, and I can mix it up anything, and that's how it is. So if I'm too fast, you can stop me for questions here. So by default, Kubernetes, when you put an RBAC rule, it's a deny all rule. So it's basically can't do anything, and this is kind of extension of the and if you don't enable RBAC, the default is allow all rule, and which is a pretty dangerous thing. And as I said, that it contains subject, verb, resource, and namespace. I'll talk about the namespace a little bit more. Namespace is kind of a grouping of resources, I would say, but you can do it at that level also. So namespace is sometimes you can separate your system based on the user ID, based on the user group, based on the environment, like a development, production, or we are using the namespace for a multi-tenant environment. So every when you have a customer, we are having a common multi-tenant Kubernetes environment. And when the multiple banks come on and use that system, for each and every bank, we have a different namespace, or every customer, you have a different namespace, so that And namespace isolation is Kubernetes is one of the guaranteed that one namespace ideally won't be able to talk to the other namespace. So that's there. So that's a different topic. We can talk some other day about how we can actually do network separation on the namespaces, and we are doing that too. Some so from the RBAC thing, role-based access control. So there are two things. One is the roles and the binding. So role is contains the rules of set of permissions. Okay, and binding grants the permissions. Okay, so and there are two types of roles. One is at the namespace level, another is at cluster level. So I'll spend a few minutes here in these slides. So first you define that, first you define a role, and what you tell the role that, yes, you are, let me go back to this slide. So you tell that, for these resources, you can do these operations. So this is how, there is no subject involved there. So only resources and operations, you kind of create it and create a role on that. But there is no user binding there. And the bindings is when you are actually binding the user with the role. And that is where you are kind of, you are binding the role binding. And these roles and role binding, you can do it at the namespace level, and sometimes and you can do it at the cluster level. So why do you need it at two levels? So some of the things, for example, all the pods, especially the pods and some of the let's talk about that, like services, deployments, and then ingress. All these things are at the namespace level. But if you talk about some of the other stuff like in nodes and then secrets, all some these things are actually will be at the cluster level. So this is when you apply something at the cluster level, this is kind of applicable to all the namespaces, and this is not going to be at the particular namespace. So, and they work very similar. So if you have a roles at the namespace level, the cluster level, it's called a cluster roles, and if you have a role binding, the cluster level, it's called a cluster role binding. I have few examples, and I think the next slide is going to make it more clear. So. So this is a kind of, if I tell them, if you want to work with the Kubernetes, first thing you have to love the YAML, which is kind of, very hard, but yeah, and there's no good, I didn't found a good editor for the YAML, it's all kind of manually hard coded things. And so you have roles here, kind of roles and the cluster roles. I'm showing it in the parallelly. What is the difference between the roles and the cluster roles? How the YAML file perspective, it looks different. So on this difference, you'll see that at the roles level, we have the namespace, and at the cluster roles level, there is no namespace there, because the cluster roles actually gets applied to all the namespace. And rest of the things are pretty much same. You have the resources, and you can actually put a multiple resources here, and you can and this is you see this square bracket. That means it is the role binding. What I'm telling is that this is the roles I'm attaching to the namespace one, and I'm attaching to the user Jane can access this binding. So Jane have access to these roles, and similar to this is a name, I can attach it to a group. I've given a group example in the cluster role binding. So here the cluster role binding is also very similar, but instead of a user binding, I'm doing a cluster role binding with a group name as a manager over there. So this is all looks so easy, right? So you create a user, you create a role binding, and you just assign to, you tell them this user is supposed to do what, and that's all. That's all it should work as is. So what's the expectation? Expectation is I'll Kubernetes favorite command kubectl. I'll create a user, I'll create a group, and I'll add John to the group. And that's all we have to do, right? But unfortunately, Kubernetes, you cannot create any user there. Yeah, it's Kubernetes only allows you to kind of create a, I think that's kind of a system user only you can create it, but you cannot create any user authentication over there. So what are the different kind of authentications that currently, so you have to use it kind of a plugins to use that to Kubernetes user. Either you can do a certificate based authorizations. So basically the certificate based authorizations, you create you create certificate for each and individual person, and those certificate you load it on your machine, and based on the certificate it identifies who you are. And so and if you go to the Google cluster, by default nowadays they are disabling the certificate based authentications. You will not be able to use it anymore. Then the third one, basic authentication. I don't know why I should call it as a basic authentication. It's just kind of you sending the password in a username colon password in a base 64 encode and sending it, but that is also a very poor authentication, and most of the kind of a cloud providers are disabling those things. Token based authentication is there. I think Google also use it, and Kubernetes does it, and you can use it. You can run a secret code. You can get the token from using the kubectl command, and that is use a token based authentication to do it. But from the corporate perspective, you don't want to do it. You typically want to do it something like a Auth0 or a LDAP integrations. And for that, you can use a third-party integrations like a DEX and OpenUnion. So we are working on the DEX to integrate with our Active Directory LDAP. And that is one of the kind of unified way we were thinking of doing it. But Google came up with an excellent idea, and Amazon have some plugins to do it. So it's not mentioned in the slide. So we are using the kind of, you can use a Google IAM. My demo today is going to be on the Google IAM. In my previous Meetup group, I actually showed the demonstration on the DEX, how to implement the DEX. If anybody is interested, you can go and look at my GitHub. It's documented there, how we do it. And for EKS, we can use something called KIAM, so Cube Identification and Identification Manager. So this is nothing new for the Kubernetes. This is how the DC Auth0 works. So a user actually kind of you use a token to kind of you log into your identity provider. So either to Google or to Facebook or Auth0, for example. I love Auth0 for their thing. And you get a token and the refresh token, and then use that token or refresh token using the kubectl command and to the config file, and then you get an authorization bearer token, and it's getting validated with the JW2 token, and it checks whether it's expired or authorized to do it, and then it works in a very similar way. That's it's a very typical Auth0 workflow here. Okay. So this is more relevant about who are using kind of have come from a web developer. They have used this a lot, and Kubernetes use the same thing. So how do you kind of analyze the JWTI and JWT token? So you can see that JWT token has basically three parts. One is the header and payload and verify signature. So one thing you need to remember that these tokens are not in encryption. These are just kind of this is an open token. It just validates the hash of that if it is coming from the right source or not. So that's all. So this is it's just check the authenticity of your request. It does not tell you, it is not an encryption. Encryption still will be covered at the SSL TLS level over there. Okay, now, so Auth0 authentication, and it's not about Auth0. Even if I've kind of covered this slide in Auth0, but I changed this demo to use a Google Auth this time. So Auth0 Connect, why kind of people like Auth0, because that's one of the approach that we are kind of thinking of using it. So when you give a customer to give a different login information, we have some customer facing applications that we can go and buy your credit scoring and everything. In that case, your authentication, we are kind of trying to enable it with a different. We can use a Google, you can use or Facebook, whatever. So it's basically you click it and tell that login with Google or login with this thing. So we don't want to implement so many things over there. We want to use it on a single platform, and that is where Auth0 we are thinking of using it, and we'll connect the Auth0 to different client providers. to get the things done. So I'm quickly coming to the demo site. So as part of the demo, what we'll do, we'll create a, we'll have two users. So user one and user two, and we'll create a namespace. And in that namespace, I'll create a production namespace. And initially, I'll have the production namespace accessed only by the user one. So I'll give the user on a role, and we'll try to access it with the user two. We'll see that user two won't be able to access it. And then we'll create a cluster role, and then we'll create a role binding. And then we'll attach it, we'll create an NGINX pod from the, before we create the role and the role binding, we'll try to delete the NGINX pod from the user two. And we'll see that that is not, you won't be able to delete it, you won't be able to create it. And then we'll try to do, assign the role to the user to some access. We'll see some get access. We'll go there and see what can he does. And then we'll give a kind of a delete access to delete the roles over there. So that's kind of my quick presentation on it. And I'll switch back to demo. Question here? Any? Okay. Okay, so this is my Google Cloud account. So I already set up two accounts, like user one at my dmilan.com and this user two. So I'll log in here. You know, if I can make it tight here, this way, right? Okay, just going down like this. Maybe this, possibly. No, definitely. Yeah, that's right. I'll take it. I'll come closer to the mouth. I think this will work. Yeah. Yeah. All right. Okay. Yeah. So these are some of the scripts that I have done it, like, you know, this takes a, and it's again on my GitHub, so you can create it. So this is how, first of all, let me just quickly create a cluster here. Sorry. So if you see the, oh, sure. Thank you. Better? Okay. Yeah, that's fine. I can. Ah. So this is how easily you can create a kind of, you know, Kubernetes cluster in the cloud. So of course I just had to create a project and put my credit card number to get it enabled. But first $300 is free. So you should try and use it right now. The nice thing about Google, it don't charge on your own, and what I have done it here, I have a domain, Milan. I created it so that I can create multiple user on it, and I've done it on my own. I can't do all these things on my corporate account, so I had to do it everything on my own. Okay. It takes a kind of, I think it will take about 3 to 4 minutes. Google is pretty fast, and if you do it the same thing in AWS, it takes about 20 to 25 minutes. I've seen that. So just a question to you, is anybody using the RBAC in your company in a different way? You? How are you doing? So are you using like the IAM, or are you using the GitHub what? So you use,
for example, the way that we use it, you have, let's say, a specific engineer that owns an application, and he needs access to our cluster prod just to, I don't know, execute a water or something of that nature. The access control is based on whether they are members of the application repo on GitHub. That's what grants them the access to it.
okay. Are you using any third-party tools like Dex or anything? Or
I think we forked a product that we found on GitHub. Well, actually, we have two things. We have FTO.
FTO. FTO IAM. Okay.
So we have, sorry, the fly is primarily used for QA. For production, we use AWS IAM for groups like IAM groups. If you're a member of that IAM group, FTO would.
You use the FTO to do that, right? Okay. Okay. And are you using the open source version of the FTO currently? Okay. So how is that? Like, do you have any? Because something that I'm also looking to do it in the AWS right now. The problem right now we have it because every different authentication in the different cloud provider have a very different way. Google have a different way, and AWS have a different way. We wanted something like in a unified way because we are going to the multi-cloud provider implementation, and that is where, and we'll have the LDAP somewhere. A corporate LDAPs are even if not an LDAP, it could be an Okta or something else. So keeping the authentication outside the cloud provider. That's why I was talking about the Auth0. So where I actually can, it works with the Auth0, and then I can actually, it's my flexibility. I can change it at any point of time. That was the concept of over there. Vault? So you're talking about the secrets, keeping the secrets. That's a,
it's a great product.
Yeah.
But I don't know if you can use Vault for OAuth. Well, I think you can at some point, but I don't think it's like the main purpose.
Main purpose to keeping the secrets for the configurations.
They might have added support to OAuth at this point. I haven't used Vault in a while, but it's a great product.
If I understand it correctly, so Vault, the OAuth provider, in this case, Auth0, is handling like the auth-in part of the transaction.
That is correct. So Auth0, you're handling the auth-in. It's telling you which groups it belongs to. It can tell you only the groups.
Right. So it creates the JWT, but the Kubernetes engine actually does the introspection on the JWT.
Yes.
To get the groups.
Groups, right.
From the
right. So you get the groups, and you do the group binding, the role binding, and basically, if you tell that the groups is doing the authorization, that's correct. But the actual job is getting done at the Kubernetes level, because that is where the binding is getting done. And that's why we are using the Auth0, because even if you have the multiple, we have our internal customer, internal people, employees. We have our information in the LDAP. We are also able to log into the system. But for our external customers, they have the systems in the Okta. OKT. So they use a Auth0 authentication, but we don't use a Auth0. So that's why we kind of, they go through authentication, it gets validated to Auth0, and then coming to the same kind of, from application perspective, it's a one Auth0, but from then I'm kind of expanding it to many different things over there. And okay, I have it ready. So what it does is, I don't like this. So when I did that, it just created, and if you're familiar with the Kubernetes files, that it created basically pulled the kubeconfig file with everything over there. So right now it's getting validated through the certificate authentication, cluster certificate authentication. This is how it is getting validated. If I don't if I take out this file, it won't be able to talk to the Kubernetes cluster right now. So if I do keep CTL get nodes, you will see it. But if I remove this, if you do this, it won't, because by default it's looking this thing. Now I pull the file again. Now I'll be able to get it. So it's getting validated by the kubeconfig, and that's because of doing the certificate-based authentication right now. And there is no RBAC. So what does that mean? That I can pretty much, this user can pretty much do anything right now. I can create, I can delete, I can create another pod, and kind of if you're familiar with that, if you are able to log into any Kubernetes system, I can inject any pod right now and log into any other system right now. That's how it is. So it's so easy right now, if you don't kind of harden your security things. So with this, now that I have it, kubectl get namespaces. Right. Oh, I forgot. I'm doing something wrong. Yeah, so it's so short from is fine. Okay, I think I did something. Yes. So I create it, and what am I doing? Yeah, I usually create a shortcut. That's the problem. Yeah, so I usually do that, and then if I do that this thing now, so that's I want to typing. It looks so bad now. So you see that production namespace is out there, and I'm going to create an NGINX pod. So if you look at these pods, and what I'm telling it that I'm creating the pod in the namespace production, and if I do it apply, it just creates the pods right now. And this is all I am doing it based on the user one. Now, if you look at these pods, you'll see that running. Okay. Now, now what I'm doing it, I think this also needs some zoom. That's fine. Okay, I'm assigning the user one an admin role. So I give that user one as an admin role, and then this is the role binding. I'll create one. And the reason I gave that user one an admin role, because the moment I put up this role, if I don't give the user one as an admin role, I won't be able to log into the system, because it's a basic RBAC is deny all. So I have to make sure that I create an admin user. I give him the admin role first so that he will be able to do it first. Now my system is RBAC is enabled on this. So what I said that I created a pod reader role, and actually I just kind of, for this demo, I have added the create, but reader role is usually get, list, and watch. I create it, so just want to make sure that anybody have this pod reader role, they'll be able to create it, but they won't be able to delete it, the role, but they'll be able to list and watch. But what I have seen it right now, I have created this role, but I have not added any user on this role right now. The role does exist, but nobody is binded to that role. Okay. So now this is the role binding. I haven't applied the role binding. I just created this role binding. Oh. Role binding file, and it tells that I have the user two. I'm binding to this role, but I haven't applied that. It just kind of, I had this role created. So at this point of time, I'll log into the user two session. How much time do you have? Okay. How much time do you have? Okay. Do you have to 10 more minutes, right? Okay. Okay. And doing this demo is easier to do it in Google Cloud because I can open a two different cloud shell with a two different user perspective. And okay. As usual, first let me pull down the cluster configurations. Wow. Okay. I think I'm using a wrong project name here. So let me, yes, it is 0724. This is not the one. Lead page. So I have to use a different project name here. Okay, so that's good, better. Come on. Okay. So I have to do this again. This I'm running on the user two. So you'll be able to see the production, but let me see. Oh, I think something went wrong. It's able to create it, but it was not supposed to create it. I should have seen a failure like this. The parts is forbidden to do the user. And then I should have done this role binding. I don't know, something might have been some configuration is wrong from here on the, that's, so this should have, no, actually, no, this should not have been done. So ideally, what should have happened that when I tried to create that pod on the user two, it should have stopped me doing it because the role was not there. But I think something went wrong on some configurations here. Might be some spelling mistake or something has happened on that, and that's allowed me to create it. So let's try to delete it. I'm not sure if it is. This is the user one. Okay, so it's definitely the RBAC didn't get applied. Some configuration was wrong on that. Okay, so that's so that is not kind of working. So I think that's kind of ending my demo here. These are some of the kind of, I have added some of the links that I have used on the RBAC. And with that ends my presentation. Thank you. Thank you.
There's still plenty left. It's serious a little bit. Thanks again, Milan, for giving us
Oh, thank you.
Appreciate it. So,
sure.
Have you guys developed any pattern for opening up cluster scope of resources to users in a secure manner to allow your users to install things like CRDs or operators and stuff like that on their own?
So do you mean that every user should have access to do it on their namespace or something like that? Or only the admin should be able to do it?
To lock things down to where they can install or delete things that they have installed as a cluster scope.
Right. So we are doing it in a many different ways. So we are doing it at the namespace. So every user will have their own namespace, and you can play with your namespace whatever you want. So you can delete objects and create objects on your namespace. You can't touch another namespace, and that's how the rollback access control I was showing you, that namespace binding over there. So you give an user to that namespace binding. But the problem with that is, we are even limiting the developers to create a namespace. So sometimes some of the applications, they want to use a multiple namespace, especially example, if somebody wants to use a multi-tenant environment where you will be using the different namespace over there. So in that case, we are thinking having a different small Kubernetes environment. If you have used a katacoda.com or something like that, if you have been there, so you spin up a cluster, like, within a few minutes, you have your Kubernetes cluster over there. So we are thinking about that perspective. So every user will have their own Kubernetes sphere, so that it's a free to do development, whatever you want to do. But that's definitely not for the beyond the developer's environment. After production environment is there.
figure out the way.
That's essentially the model that we use where we do one application where both that is explicit already required to handle that we can't implement the system in the cluster, like that cluster implements as opposed to lose its own security. So we're looking at potentially playing around with the policy agent to be able to violate specific CRDs for specific
So you want to have a different CRDs for different user groups, right?
Yeah.
Yeah.
So like we don't want to have to manage solid CRDs for hundreds of different companies.
True.
But we also don't want to open up to where one team can CRD.
Yeah, that's the problem. CRD is at the cluster level. It's not at the namespace level. Yeah. So
There's a lot of stuff out there where we don't want to take the risk of downloading operator X from some random GitHub.
exactly.
And installing it, but development team might want to do that.
Oh,
My team's not built for that, so we're like ways
exactly. So in Equifax, they blocked the, they not now, they had blocked the Docker Hub. So you practically can't do it, any developer can't do anything, right? So that's why you internally wanted to have our internal Docker Hub, but it's not always possible to do that. It's so huge efforts to do it. So we again need to open up only for the development environment, and we do the build that, it won't use the Docker Hub. That's the idea doing it. Yeah. But you're right, that's a challenge right now with the especially with the so many Dockers are existing, so many operators existing, and you don't know what's coming to your system right now. That's a problem. And so you know that some of these Docker images, like you have seen that Alpine Securities and everything, like and they had a blank password, so you can practically log into that. You create a Kubernetes, you create a Docker pod over there, and you log into like do a BNSH, and then you can connect to any pods internally using the root passwords, and you can play around with that applications. You can practically go into the pod and change the configuration files over there.
Docker registries. Anybody doing that right now? And what are they using for that? We use something slightly different approach. We have like our own registry instance that runs the backend of S3 bucket. So the way that it's set up right now, we have just one S3 bucket for pushes, but for both we use CloudFront as a CDN for that bucket. So you can pull from pretty much everywhere. So we have a registry instance running in Europe and a registry instance running in the US. So that the pulls are, the latency is pretty much non-existent. When you push, it comes from your table. So with AWS specifically, I know that you can use something like S3 accelerated access. So I don't remember the exact name they have, but for that you can also have more bandwidth.
The one thing I'll say there is Arbor has image vulnerability scanning where that works. It's got no geo. It's also has image signing available via free. That does not work. Because the image is signed to registry. That registry stores pictures that identify so that signing everything that does not get replicated yet. Actually, that would be yesterday, and that's going roadmap at there. Don't have crash supply or tracking or cache peer-to-peer.
So are you using the Docker registry in
We are, yeah, we are, but we're doing it as an outbound deployments, and that's all kind of configured in there, and it'll automatically reach out and pull vulnerability databases. And then you can set policies at a global scope for like full policy to not allow any they have those severe vulnerability like security low, high, or above. You can also set that per project.
Yeah, experiment with Clay, and you run Clay, you have to connect it to a player that's supposed to be running on your end. Our players get crashing all the time.
Yeah, we're still in like the initial phase. Like part of 1.8 application features, first time we really look at it since we actually implemented the NGINX application. If you want an NGINX setup without that, you have to be responsible for those credits and plugging into that as like external data sources. Not possible, but not trivial. And they don't have a lot of good documentation of that model. So we've looked hard for a while and just at the point where we're looking to scale it up.
So, if I dig in the Django, like, is that GeoDNS? Like, how is that?
So to give you a rundown of how we do it is for ingress on our cluster, we use a wildcard DNS, wildcard is a self-serve.
Yeah.
And we tend to use similar serve for like a group of clusters that kind of represent one piece of environment. And within that, we bake the geo SANs into the certificates with DNS. So we can deploy it with like a cluster, partner.cluster one, and then partner.cluster two, and partner.geo will also involve
Are you trying to get a duplicate wildcard server because that's the compromise safety? Any bug can attack your entire Kubernetes could be attacked because of that wildcard server.
Yeah, this is for our on-premise clusters only, and we don't have the same picture. Well,
There's something like
it's something like there's an external DNS provider that plug in like our on-premise DNS and stuff like that. It's kind of hard to do. So yeah, it is all that stuff, but what we have to do.
Working on the acting, like start manager thing.
Yeah, that
automatically assign
it doesn't apply for us for our knowledge.
Something like that.
Got to be from our own internal CA.
Okay.
Getting like intermediate trust and factors is even more complex than getting all parts.
Okay. So even you can I have gotten a global the internal certificates that you can move to the cloud. Certificates and all those things come from the Google. They automatically approach the certificate, but that's at the Kubernetes level. But at the application level, if you're using the certificates, you cannot type in you. Typically, the use cases will go for the wildcard certificate. But just thinking of using the cert manager, there's some application.